And this question is given that an incompressible fluid flow steady through a cylindrical pipe which has a radius 2r at point A and radius r at B. Further along the flow direction, its velocity at point A is v, its velocity at point B is. So in this question it is given that an incompressible fluid flow steady through a cylindrical pipe which has a radius 2r at point A. So consider that at a particular point its radius is nothing but 2r, and at a point another point its radius is becomes equal to r. So let's say radius of this point is equal to 2r and radius over here is equal to, take it as something but r, and the velocity at point A is v. So over here take it as velocity is v, and rm is to find out what about the value of velocity over here, take it as something but v2. So you can use that continuity equation, that is a1 v1 is equal to nothing but a2 v2, and a1 can be written as nothing but area can be written as pi into r square, so it is 4r square, which we can take it as 2r square. So this a2 can be written as nothing but pi into r square into v2. So we can cancel this pi and this pi over here, this r square and r square over here. So we can write the value of v2 is going to be 4 times of velocity v1, or 4 times of v.